Now we are going to discuss Cauchy-Riemann equation in polar form. Statement goes like this: if f of z is equals to, z means in case of polar form we are going to write r e raised to I theta. Okay, so f of z is equals to f of r e raised to I theta can be rewritten as u of r comma theta plus I into v of r comma theta. This even we can take this as a w is equals to. Okay, so E is analytic at point z is equals to r e raised to I theta. Then there exist four continuous first order partial derivatives. Those are do u over do r, do u over do theta, do v over do r, do v over do theta, and satisfy the equations do u over do r is equals to 1 over r, do v over do theta, and do v over do r is equals to minus 1 over r do u over do theta. So similarly we can write with the help of the same thing, we can write in subscript from u subscript r is equals to 1 over r v subscript theta, and v subscript r is equals to 1 over, minus 1 over r u subscript theta. R u r is equals to v subscript theta, and r v r is equals to minus u subscript theta. This is the statement. We'll look at we'll go for the proof part now. Okay, now let us move for the proof part. So proof, how we are going to, so this is proof. So here let this function f of z, a single valued function f of z, be analytic at point z is equals to r e to the power I theta. So if it is analytic, then by definition, so what we can write, f dash of z is equals to limit, okay, delta z tending to 0, okay, f of z plus delta z minus f of z over delta z. This is our definition, and it exists, okay, and unique. Okay, so now in the polar form, how we are going to write this? Z is equals to f of z is equals to u of r comma theta plus I into v of r comma theta. We are going to write like this, and this delta z is nothing but increment in z. Okay, so again we'll get delta r and delta theta. Those are the increments in r and theta. Okay, so now the same function, this derivative, how can we rewrite f dash of z with the help of this concept? Okay, f dash of z is equals to limit this delta z approaches to 0, okay, u of r plus delta r, okay, since it is an increment, comma v theta plus delta theta, okay, plus I into v of r plus delta r, comma theta plus delta theta, okay, minus into bracket only real part, this f of z, what we have, u of r comma theta plus I into v of r comma theta, okay, whole divided by this delta z. I'm going to write it as a delta z. Okay, now I'm going to separate real part with real part and imaginary part with imaginary part. So this is equals to limit delta z approaches to 0, u of r plus delta r, comma theta plus delta theta, okay, minus u of r comma theta whole divided by, this is delta z, okay, plus limit delta z, limit delta z tends to here 0, okay, what we can write, imaginary part, that is here I plus limit of this, what we are going to write here, u of r v of r plus delta r comma theta plus delta theta, okay, minus v of r comma theta whole divided by delta theta. Let me consider this as equation 1 for our further study. Okay, consider this z is equals to r e to the power I theta. This z is a function of r and theta. Okay, then this delta z is equals to, we can write this as dot z divided by dou r into delta r, okay, plus dou z over dou theta into delta theta. Okay, so z is nothing but r e to the power I theta, so delta z is equals to dou by dou r, okay, z e to the power I theta into delta r plus dou by dou z of, again this z is nothing but r e to the power I theta, okay, into delta theta. So if we differentiate with respect to r, this is r e to the power I theta, with respect to r, if I differentiate, what we are going to get, e raised to I theta delta r plus, here with respect to theta, if I differentiate, I r e to the power I theta delta theta. This is what we are going to get, means delta z is equal to. So this one we are going to use in our equation 1. So as this delta z tends to 0, there are two cases we are going to have, that is delta r may tends to 0 or delta theta may tends to 0. Now look at look into the case 1. Okay, so here in case 1, let delta theta is equals to 0. As delta theta is equals to 0, it means what happens here, this delta z is equals to e to the power I theta delta r, we are getting, means this delta theta, this whole term is going to be 0. Okay, and as this delta z approaches to 0, this implies delta r approaches to 0. Okay, so therefore equation 1 becomes f dash of z is equals to limit delta r tending to 0, okay, u subscript r plus delta r comma theta minus u of r comma theta whole divided by, okay, e to the power I theta delta r, okay, plus I into limit this delta r tending to 0, v of r plus delta r comma theta, because delta theta is 0, okay, minus v of r comma theta whole divided by e to the power I theta delta r. Now again by definition, what we can do, this if I take this e to the power I theta common term, okay, so what happens here, so this becomes f dash of z is equals to this 1 over e raised to I theta into limit delta r tending to 0, okay, so this one is u of r plus delta r comma theta, okay, minus u of r comma theta, okay, whole divided by delta r plus this is I, okay, limit delta r tending to 0 r plus v of r plus delta r comma theta minus v of r comma theta over delta r. Again, by definition, so of this partial derivative, we can write this as e to the power minus I theta into bracket do u over do r plus I into do v over do r. Okay, let me consider this as equation 2. This is f dash of z is equal to. Similarly, we'll go for case 2. In case 2, what happens? Let us consider delta r is equals to 0 now. Okay, then delta z is equals to what we are going to get? I r e to the power I theta delta theta. And as this delta z approaches to 0, so this delta theta is also approaching to 0. So now what happens? Equation 1 becomes this f dash of z is equals to limit delta theta tending to 0. You can write this as u of r comma, because delta r is 0, theta plus delta theta, okay, minus u of r comma theta divided by this is I r e raised to I theta delta theta. Okay, so plus I into bracket I limit delta z approaches to 0. Here v of r comma theta plus delta theta minus v of r comma theta divided by I r e raised to I theta delta theta. Again, what I will do, I will take this e raised to I theta common, that is f dash of z is equals to 1 over I r, okay, e raised to I theta. If I take common, what happens here? We are going to get limit delta theta tends to 0 u of r comma theta plus delta theta minus u of r comma theta divided by delta theta, okay, plus, okay, I, okay, I into limit delta theta tending to 0 v of r comma theta plus delta theta minus v of r comma theta whole divided by, okay, delta theta. Okay, so again, by the definition of partial derivative, we can write like this. This is 1 over I is nothing but what? Minus I. So what we can write here? 1 over r, okay, minus I e raised to I theta into bracket do u over do theta plus, okay, I into do u over do v over do theta. Okay, so if I multiply this term inside, okay, so what happens here? E raised to I theta into bracket minus I over r do u over do theta minus I into I square, that is I square is minus 1 minus minus plus this is 1 over r do v over do theta. Okay, so let me consider this as equation 3. Okay, so from 2 and 3, okay, if we equate real part with real part and imaginary part with imaginary part, what we are going to get? Do u over do r is equals to 1 over r do v over do theta and do v over do r is equals to minus 1 over r do u over do theta. This is CR equation satisfied.